Good morning, students. How are you all? Hope you're all good and also serious about your coming exams. So, this is Vasu sir, faculty in physics. Today, I'm going to discuss with you uh, some problems related to electrostatics. In that, too, particularly electric charges and fields. Okay, now I'll share my screen and we'll discuss together. Right. The electrostatic force on a small sphere of charge zero point 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 newtons. First bit A given, what is the distance between the two spheres? Second, what is the force on the second sphere due to the first? So by seeing this, I can say this is the 0.4 microcoulomb charge body. Let me write 0.4 microcoulomb charge body. And this is of minus 0.8 microcoulomb. Be remember this minus denotes negatively charged body. The sphere has negatively charged body. Here this is a positively charged body. So next, how much force these are experiencing? These are experiencing a force of 0.2 newtons. What kind of forces? Since unlike charges, these are unlike. Okay, one side positively charged body is there, another side negatively charged bodies. So they will attract with each other. Okay, due to unlike, they will attract. They will attract. So nature of force is attractive force. Attractive force. This we are confining first. With what force they are attracting? Those two 0.2 newtons force. So this body is attracting with the force of 0.2 newtons, and this second body is also with the same 0.2 newtons force it is attracting. So you see the second bit. What is the force on the second sphere due to the first? Force on first due to the second. Magnitude equals to force on second due to the first. That is equals to 0.2 newtons. That's it. Means for second, what we can say, the same force. With what force this is attracting, the same force will act on this, right? So for second bit we answer. So for first, I'm answering for this B bit. Next, coming to A bit, what is the distance between the two spheres? Distance between the two spheres. From basic formula we can write it, no? Isn't it? What is the basic formula here? According to Coulomb's observations force magnitude, that is 1 by 4 pi epsilon naught q1 q2 by r square is there. So distance we should write, means r to be calculated from this. Okay, if I write for, okay, here only I will substitute, then we'll get the r value. Okay, now see. Therefore, so much 0.2 newtons. 1 by 4 pi epsilon value 9 into 10 power 9 into Q1 how much? 0.4 micro. Students, micro means 10 power minus 6. Okay, into Q2 is 0.8 micro. Students, you see here minus 8 microcoulomb charge is there. Minus denotes only negative charge body. For that only minus sign is written, but its magnitude is 0.8. That only you have to write in the equation. Okay. Now divides by r square is there. This r we have to find it out. Now let us take the next step. A simple mathematical simplification. 0.2 here 0.4 is there. It goes 2 times, and r square I'm writing on the LHS. So 9 into 2 into 1.2 into 0.8. That means 1.6 into 10 powers. If I simplify, here 9 is there, minus 6 means minus 12 plus 9, so minus 3. Okay, divides by 1. This side 1 is there, na? So let it be. So next, r square is nothing but this 9 into 1.6 becomes 1. Okay, 14.4. 16 9s are 144. Na? Likewise, 10 power minus 3 So if I write for the next one, this means 1.44 into 10 power minus 2. So R is nothing but 12 12s are 144. So this can be written as 1.2 into 10 power minus 1. Okay. So that means here R is equals to 0.2. Okay. Meters. 0.12. So this is 0.12 meters. So with this separation, two charged bodies are there. Right? So here you see, for 2 bits we are answered. What is the separation? For that, we have given it as 0.12 meters. What is the force on the second sphere due to the first? Okay, both are experiencing the same forces. Okay, that is with 0.2 newtons. This is regarding the second problem. Now let us go for the third one. NCERT third question. Check the ratio K square by G MEMP is dimensionless. Look up a table of physical constants and determine the value of this ratio. What does the ratio signify? See, students, in this 1.3 is saying that he himself saying that it is the ratio K square by GMEMP. Look up the table. Okay. In NCERT textbook table is different tables are given. In that one of the table that which denotes the physical constants values, right? Like a universal gravitational constant capital G, basic charge value. Many are there, like mass of proton, charge of electron. Likewise, many are there. Many constants are there. So once for completeness sake, I'll show here. Okay, you can also glance from NCERT textbook. This is the table in appendix A3. They given. Okay, like this speed of light to charge of electron. Here, what are the required parameters for us? For that, I will choose. Here you see what is saying. Ke square by. Once let me write for this. Ke square by. This ratio is Ke square by. Very simple one actually. MEMP. Usual meanings of these letters, if you see, K, it's basically 1 by 4 pi epsilon naught. In electrostatics, constant into Q1, Q2 by R square is equals to F, like that we will write. Q1, Q2, in place of that, E into E is there here, if you see, if you observe carefully. And also I can say this is the ratio of electrostatic force to gravitational force, this ratio. Okay, in electrostatic force, constant into Q1, Q2 by R square. In gravitation, force between two massive bodies, for that we have equation like this. G M1 M2 by R square. Let me write this. Okay, force in electrostatics is constant into Q1, Q2 by R square. Here in gravitational force, G M1, M2 by R square. If you take the ratio, what happens? This R square gets cancelled. This ratio comes like. So for this we are going to find out. So constants ratio we have to. Here you see the table, the required one. Charge of electron E into E is there now, and next gravitational constant is there now. Next mass of electron is there. Next mass of proton is there, and also what we have next one constant. This one K is there now. So likewise, these parameters are required. So what are these values? If you see, mass of electron, basic charge, the nature is this value, 1.602 into 10 power minus 19. Okay, for our mathematical convenience, what we'll write 1.6 into 10 power minus 19 coulombs. Next, universal gravitational constant, this is the value. And next, mass of electron, you have to observe this one, 9.1 into 10 power minus 31. Mass of proton, 1.673 into 10 power minus 27 kg. Yeah, these 10 power orders are very important for us, we remember. And next, this constant value, already we discussed 8.987 into 10 power 9 is given. I written like 9 into 10 power 9. Okay. So these are the constants values, what they mentioned in the table. The same values we are writing here. Okay. Now you see 1 by 4 pi epsilon 9 into 10 power 9. E square means 1.6 into 10 power minus 19 whole square, whole divides by G. How much? 6.67 into 10 power minus 11. Next, mass of electron 9.1 into 10 power minus 31. Mass of proton 1.67 into 10 power minus 27. Okay, that is equals to. Okay, if you're solving for all of this, you're going to get for a value of 2.3 into 10 power 39. 10 power 39 is the ratio, is the final value, right? So likewise, okay, we are getting value for this. What does the ratio signify? What does this ratio signifies here? It's the ratio of electrostatic force to gravitational force. And coming to the next one, that is the fourth problem. See here. See students, fourth one is given like this. Explain the meaning of statement electric charge of a body is quantized. So, electric charge of a body is quantized. That statement we have to explain the meaning. Say this is a charged body, positively charged body. This charge is quantized. For that we have to explain. Okay, let me take like this. First, let us understand what exactly is a charged body first. What is the meaning of charged body? Students, tell me. What is the meaning of charged body? Say this is one body. If I say this has positively charged, what is the meaning of it? It means lack of electrons or deficiency. Deficiency. Deficiency of electrons body is said to be positively charged body. It is said to be positively charged body. Suppose if I say negatively charged body, I'm calling this as a negatively charged body. What it means? Excess, more number, excess number of electrons body. It is said to be negatively charged body. Negatively charged body. Whether positively charged body or negatively charged body, on what basis we are deciding? The number of electrons. Number of electrons. Based on that we are deciding. So whenever electron is moving or transferring from one body to another body, then we can say one is a positively charged body, the second one is negatively charged. The one which is losing is said to be positively charged body. The one which is gaining is said to be negatively charged body. Suppose one electron is reaching from this body to this body. So that time what we are saying, this is of E, 1E, positively charged body, and this is of 1E with a negative charge, -1. Suppose if it loses 2 electrons, what we can write? Plus 2E, here it is of -2E. If it loses 3 electrons, what will write? This has a plus 3E and this has -3. So, whenever we are expressing the charge over on body, okay, it is described with the number of electrons. So half of the electron cannot reach from one body to another body. So in terms of fractions, we cannot express charge over one body. In terms of fractions, it is not possible. One charged body, one electron can reach from this body to this body. 3/4 electron or 1/2 electron or 1/4 electron cannot be realized. So that is the reason why always a charge over one body can be expressed as integral multiple of basic charge. Integral multiple of basic charge. What is the basic charge we have in the nature? Charge of electron. So plus or minus Na. Okay. Where this n is nothing but integer. This n is nothing but integer. Integer means n is equals to, okay, like 1, 2, 3, and so on. Likewise. So, in that way, charge is quantized. Charge is quantized. Okay, level wise. 1, 2, okay, 3, 4. Likewise, it is quantized. It is not a continuous one. It is not a continuous one, right? Next, next we have to answer for B bit. Now this is the explanation for A. Coming to the B. Why can one ignore quantization of electric charge when dealing with macroscopic or large scale charges? Large scale charges or macroscopic charges, both are same. Okay, why we have to ignore in such cases? Okay, what we are ignoring? Quantization of charge. On which conditions we are ignoring? For the case of macroscopic charges. Macroscopic charges. You see, macroscopic means a big size. Okay, large size charged bodies. For B, if you are asking, suppose you see here, this is the one charged body. Say this as Earth. This as Earth. It is the big source for electrical charges. Let me say like a number of positive charges. Yeah, okay. Number of negative charges it has in it. So this is the big source of electrical charges. What I can say? It is the big source. It's the big source of electrical charges. So as compared to these millions of electrons, millions of charges, this 1e to e, that number is very less. Na? This 1e to e number is very less. Na? Millions of charges are there, more than millions also I can say. So that is the reason why on macroscopic system, macroscopic scale, or large scale bodies, he told in this question, you see, large scale charges. So for those, this quantization of charge can be ignored. Doesn't matter here, right? Like in one ocean, one spoon of water, if you are taking out, or even though you are pouring in it, how that level cannot be altered. Likewise, this is very minute one. So in that way, we can understand and we can give the reason. And next, the fifth one is here. The NCERT fifth question. When glass rod is rubbed with silk cloth, when glass rod is rubbed with silk cloth, see here. Here is the glass rod and here is the silk cloth. Terms are there. Charges appear on both. Yes, obviously. A similar phenomena is observed with many other pairs of bodies, right? Explain how this observation is consistent with the law of conservation of charge. Okay, this is the law of conservation of charge. This is inconsistent with the law of conservation of charge, this phenomena. That for that we have to explain. Very simple thing here you see. And also I'm showing in one diagram for this. Very simply you can understand. Suppose here you see, this is the glass rod. Where is the glass rod? This is the glass rod. Here is the silk cloth. When we rub these two bodies, this silk cloth, this glass rod to silk cloth, electrons will transfer. So that time what happens? This glass rod will get positive charge. Silk cloth will get negatively charged. So the one which is losing electrons will be positively charged one. The one which is gaining electrons is said to be negatively charged one. So see here, this is the glass rod, and next this is the cloth with a negative charge. This is with a positive charge. This is a cloth with a negative charge. Now, for this in continuation to this, what I'm saying, one more glass rod rubbed with this silk cloth is brought near to this glass rod. Since that the second rod also positively charged, this is already having positive charge, both will repel. Two glass rods will repel. Likewise, for one more silk cloth, if I rub with the glass rod and brought near to this cloth, that already, which is negatively charged one, again two cloths will get repelled due to like charges. So plus repulsion, minus repulsion. Plus means this two glass rods, those which are rubbed with the silk cloth, and minus means negatively charged one. This silk cloth and another silk cloth that again which is rubbed with the glass rod. So these will repel. Now coming to this glass rod and this silk cloth, okay, which are having positive charge and negative charge, they will attract. These two will repel in this case. Okay, this glass rod and this silk cloth has to attract, since unlike charges, these are unlike charges, right? So this is the explanation, and I will continue from here for the given question. What is saying? Okay. A similar phenomena is observed with many other pairs of bodies, and explain how this observation is inconsistent with the conservation of charge. Here you see conservation of charge, how to realize this glass rod is losing the electrons, this silk cloth is gaining the electrons. So it is conserved in a charge is conserved in isolated system. Charge remains constant. Charge remains constant. That is nothing but conservation. Okay, it is nowhere it is going away. So it is constant. So in this example, we can show this is inconsistent with the law of conservation of charge. And also is asking for many other pairs. I'll show one or two examples here the same way. Here you see this first case. In this case, here is the knob, metal knob is there, a round handle. This is called a knob fixed door. Here one boy or man or woman is trying to catch this knob. So sometimes, we remember what happens? Sometimes, okay, what happens? This man or woman may experience a mild shock from this knob. A mild shock. Since if it is a charged one and this finger is also charged one, okay, then there is a chance of passage of electric current. So mild stroke person can feel. So here one is losing the electron, another one is getting the electron. Charge flow is observed. That's why shock they are feeling the shock. Next, the second example here, one boy is trying to comb. After combing, what happens? He brought that comb near to here. This hair must be driven, should not be wet. So in such case, when he tried to bring this comb near to paper flips, okay, small pieces, then paper flips. What happens? Those will try to attach this. Those will catch this one comb. Since again electrically charged one. This is a charged body. Again, this paper clip also a charged body. So conservation of charge is realized even in these examples. So likewise, students, we have some examples here, right? I hope you understood. Okay, today's class, and now you see. What actually we discussed, say this is the first problem, okay? Two spherical bodies, charged bodies are there, and is asking to find the force, a very basic model, and thereafter, okay, they're given the force, but they're asking for the distance and force on the second body they're asking. If you know the concept, it is not a big task. And next, some constants they're given and asking the ratio value. Okay, these constants, even though we are not looking into the table, we have to remember for this, being a science students. Okay, and thereafter, coming to the fourth question. So a very conceptual question, quantization of charge based on quantization of charge. It's given Q is equals to plus or minus Ne. So next, okay, the last one for this today's class, and one example related to conservation of energy they given and asking the explanation. Okay, hope everybody are understood for this. Okay, thank you. We'll meet in the next session. Okay, I'm winding up. Thank you all.